In this session, we will understand the data warehousing concepts. First of all, there is a need to understand why we require a data warehouse. And before that, what is a data warehouse? Data warehousing combines data from various sources into one single database which can easily be manipulated. Hence, we get data from various sources, and this huge amount of data is stored in a data warehouse. So this huge amount of data that is stored is used for analysis, transformation and reporting purpose. Now, what is the need for data warehouse? Every organization has to maintain data. Large data, it could be more than thousands or millions of customers, cannot be handled by books or Excels. Here is when there is a need for data warehouse. So if we have a huge large amount of data, we cannot maintain that on books. So we need a proper database, and that also structured properly to handle the huge amount of data. In the challenging good times, decision making becomes important. The best decisions are made when all the relevant data taken into consideration. The best possible source for that data is well designed data warehouse. Now for the decision making, consider you have a retail store, and what you need to know is that in which year the sale was more, or which offers brought up more sales. So you should have the previous data or the history data in your system so that you can do the analysis for better decision making. Next is the dimensional data model. So now you know what is the data warehouse. Now to create the data warehouse, to structure it, there is a data model in place known as dimensional data model. So it is further categorized into two, that is star schema and the next one is snowflake schema. First of all, we'll learn about the star schema. Star schema consists of a fact table in middle and the dimensional table around it. So as you see in the diagram shown here, we have a fact table in between, and surrounding it we have the dimensional table. The dimension table have the reference information, and a fact table contains the foreign key to all the dimension table and the data to be measured or analyzed. Basically, the fact table will have all the foreign keys to the dimension table, and also it will contain the data that needs to be measured or analyzed. The primary key in dimension table is represented as a foreign key in fact table. So this is the star schema, and it is mostly used for structuring the data warehouse. The next one is the snowflake schema. This is an extension of star schema, as you can see in the diagram, wherein each point of start is divided into more granular level. So here and also you can see that we have the fact table in middle and the dimensions are surrounding it, but we are also dividing the dimensions into more granular level, so dimension is further connected to other dimension. So this is the snowflake schema. Next is SCD types. So SCD stands for slowly changing dimensions. You know that dimensions contain the reference information. So slowly changing dimensions are the dimensions that change slowly over time rather than changing on regular schedule. So in general practice, you while you are doing the ETL work, there would be some scenario wherein you need to handle these slowly changing dimensions. So generally to handle it, we have three types of solution to handle the slowly changing dimension. The first one is SCD type 1. In type 1 slowly changing dimension, the new information simply overrides the original information. In other words, no history is kept. So if a data is changed in the slowly changing dimension, then the new record replaces the original record, and this is the main disadvantage of this SCD type 1, that we cannot maintain history while we handle this the slowly changing dimension using type 1. For example, we originally have below record in the table. Employee ID is 1, and for this employee ID name is Tuhina and state is Punjab. Now consider that employee Tuhina is moved to state Haryana from Punjab. Now the new record would have the state as Haryana. The new information replaces the original record. Now we have the below record in the employee table. That is, for the employee ID 1 name Tuhina, the state would be Haryana now. So the old information, that is state Punjab, is now deleted from the table and a new record is inserted with the new value. So this is type 1 to handle the slowly changing dimension. Next we have SCD type 2. This is the second method. SCD type 2 keeps the full history of records. So this is the main advantage, wherein we want to maintain the history of records for further analysis. So SCD type 2 keeps the full history of records. When value of a particular record is changed, the current record is closed, a new record is created with new values, and this new record becomes the current record. So what we do is we deactivate the original record, but it remains in the table, and we create a new record with the current state. Each record contains the start time and end time to identify the time period between which the record was active. So this table would be having the start date and end date, which will define that which is the current record and which were the previous records. For example, we originally have below record in table with employee ID is 1, name Tuhina, state is Punjab, start date is 1st April 2018. It is the time when this record was inserted in table, and end date is 1st Jan 2999. So the end date 1st Jan 2999 is some future date, and it makes that this is the current active record here. Here the end date is some future date, making this record as active. Consider employee Tuhina now moved to state Haryana from Punjab on 9th of March. This record will be closed and a new record will be created with the changed values. So now we will have two records for Tuhina, one with the original value and one with the new value. So for the first record, wherein the employee ID is 1, name is Tuhina, state is Punjab, start date is 1st of April 2018, and end date would be the as of date now. So we are closing this record, or we are deactivating this record by changing the end date to as of date. Now we have another record with employee ID 2, name would remain as Tuhina, state would be Haryana. This is the changed state. Start date would be the as of date 9th March 2018, and the end date would be some future date, that is 1st Jan 2999, considering to make this record as active one now. So the active record is 1 with state as Haryana. Next we have the third type, SCD type 3. SCD type 3 stores two versions of values for a particular selected level attribute. Each record stores the previous value and the current value of selected attribute. When the value of any selected attribute changes, the current value is stored as the old value and the new value becomes the current value. This means By using SAD type 3, we can only maintain the first level of history, not all the history over time. We only have the latest history available for that particular record. For example, we originally have the below record in table, wherein we have employee ID is 1, name Tuhina, original state is Punjab, current state is also Punjab, and effective date is 1st April 2018 when this record was inserted. Consider employee Tuhina now moved to state Haryana from Punjab on 9th of March. Now the original state would become Punjab and the current state would be the new state, that is Haryana. The original state and current state will be modified on the effective date. So as in for employee ID 1, name Tuhina, original state is Punjab now and the current state is Haryana, and effective date when the state is changed from Punjab to Haryana would be updated, that is 9th March 2018. So this is the third type of handling the slowly changing dimension, wherein we only maintain the latest history. Next we have OLAP and OLTP. First one is OLTP system. So this system, that this database, is characterized by large number of short online transactions. Transactions could be insert, update and delete. The main focus of OLTP system is put on very fast query processing, because OLTP system, that is online transaction processing system, contains the transactional data. Whatever transaction is happening on the front end, you can say, that is stored in OLTP system. So it should be very fast because it would have many insertions, update or deletions. And the effectiveness of this system is measured by number of transactions per second. Next we have is OLAP, that stands for Online Analytical Processing System. So this is a database that is characterized by relatively low volume of transaction. For OLAP system, a response time is effectiveness measure. OLAP applications are widely used by data mining techniques. So what happens is OLTP system feeds data to OLAP system for analytical purpose. So we basically do the analysis over OLAP system. So there would be very few transactions happening on OLAP system. This system is basically, we have the aggregated or historical data stored in OLAP system, and that is stored in multi-dimensional schemas, usually star schema. So this is the diagram where you can see that the business processes we have, for business processes we have OLTP operations, and this OLTP system feeds data for business data warehouse known as OLAP system. In general, we can assume that OLTP systems provide source data to data warehouse, whereas OLAP system help to analyze it. Next we have some questions on this tutorial. The first question is, the full form of OLTP is, so the full form of OLTP is Online Transaction Processing. So A is the correct answer for this question. Next is, the data is stored, retrieved and updated in which of the following system? So most of the transactions, that is insert, update and delete, happens in OLTP system, that is Online Transaction Processing System. So the correct answer for this is A. Other than this, we also have another system known as OLAP, that is Online Analytical Processing System, wherein there are very few transactions that are being happening, and this is basically used for analytical purpose. to do the analysis on the data. The next question is the type of relationship in star schema is. The correct answer is C, one to many, because we have the fact table in middle and we have multiple dimensions surrounding it. So the relation becomes one to many. Next is data cleaning is. So by data cleaning, we mean that we want to remove the redundant data or erroneous data that we do not want. So in common process, once you have the data in place, you would be removing the unwanted data, that is basically known as data cleaning. So data cleaning is the removal of errors and incorrect input from a database. So this is the correct answer is B.